Hello, everybody. Today we're going to be going over Gaussian elimination, otherwise known as reduced row echelon form, for solving systems of equations. So, let's give an example system. So, we have 3x plus 4y is equal to 23, and we have negative 2x minus y equals negative 7. Okay. So how Gaussian elimination works is we're going to turn this into a matrix. So we have an x and y column, and then we have our solution bar. This is all the stuff on the right of the equal sign. And then we'll close that. Okay? So our x terms are 3 for the first one, negative 2 for the second one. Y terms are 4 for the first, and negative 1 for the second. And then for the bottom, it's negative 7 on the right side, and it's 23 on the left side. Or, sorry, on the right side for the first one. So now what we're going to do is we are going to try to perform row operations. We want to get something like this. We want to get, some, values. So in this case, this is be x and y. So those things on the right of the equal sign, those are going to be our x's if we get it in this form. Okay? So let's perform some row operations to see if we can reduce this. So we have this current one, and we want to go with our ones first. We want to try to get our ones first. So I see a 3 and a negative 2. Those look, they look 3 minus 2 is 1. So I think that is something we can go for. So our first operation is row 1 plus row 2. And whichever one is the first, this is the one we're operating on. We're keeping the entire thing the same, besides the row 1. Okay? So this is going to be row 1 plus row 2. We're going to have 1. 4 minus 1 is 3. And then we're going to have 23 minus 7, which is 16. And then let's keep everything the same on the bottom. Okay. So now, let's move on. So we have a 1 now, but let's try to make a 0. So one way to do this is we can change row 1, and we can add it with 3 row 2s, because we're going to have a positive 3 in row 1, and 3 row 2s we're going to have a negative 3, so that means we're going to have 0 at the top row. So we're performing on row 1 still. So we're going to have negative 5, 0, negative 2, negative 1, and then we're going to have negative 5, and then negative 7. Okay. So our next step, you can take multiple steps, but what I want to do is I want to get a 0 in the second row. I want to make this 0. And the way I want to do that is I want to find the common factor between 5 and 2, which is 10. And our third step, I'm going to say, is 5 row 2s, and we're going to subtract 2 row 1s. So we're going to be left with -5, 0, 0, -5, -5, and 25. Okay. And as you can see, we have a pretty obvious next step. We see we have a common factor of -5 in all of our, oh, sorry, this is supposed to be negative. We see we have a common factor in all of our elements, so we could just take row 1 and let's multiply it by -1/5, otherwise divide it by -5, and then we'll do row 2 times -1/5. So then we're going to be left with this matrix. So we're going to be left with 1, 0, 0, 1, and then we're going to have 1 and 5 over here. So, as said earlier, our solutions are going to be right here. These are where our solutions are going to be. So, x equals 1. X equals 1. Y equals 5. So the answer is 1, 5. Hope everybody enjoyed this quick tutorial. The main concept of Gaussian elimination or reduced row echelon form is that you perform row operations. You have to remember that the first one you do, that's the first one, for example, on step 2, we took row 1 plus 3 row 2s. We only modified row 1. But when in step 3, when we took 5 row 2s minus 2 row 1s, we affected the row 2. So the order does matter, technically, when it comes to these things. Anyways, I hope you liked this video, and I will see you all later. Goodbye.